Alright, today's topic that we are going to cover is permutation and combination. In this chapter, the first thing that you should be aware of is the concept of factorial notation. Now, 5 factorial, 3 factorial, what does that mean? That means that 5 factorial is the short form of writing the product of 5 times 4 times 3 times 2 times 1, and 3 factorial is the short form of 3 times 2 times 1. So 5 into 4 into 3 into 2 into 1 can be written as 5 factorial. This is the symbol for factorial. Okay. And if we are asked to simplify 5 factorial upon 3 factorial, let's say. So 5 factorial upon 3 factorial is going to be 5 into 4 into 3 into 2 into 1. Can I say 3 into 2 into 1 as 3 factorial?
Yes.
So I can cancel that out because 3 factorial is 6 and 3 into 2 into 1 is also 6. So the final answer is going to be 20. Similarly, if you have, let's say, 11 factorial over 8 factorial times 3 factorial, so we know 11 factorial can be written as 11 times 10, 1 less than the number, times 9, times 8 times 7 all the way. But instead of writing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, I can write 8 factorial so that I can simplify that with the denominator. So 8 factorial got cancelled out, and 3 factorial is basically 6. So I can simplify this, and this is going to come out as 165. Okay, that's just the concept of the factorial notation. Then we are going to discuss what do we mean by arrangements. Arrangements, if you are asked to arrange 3 books on the shelf, there are 3 books A, B, and C, and you need to arrange them on a shelf. So, what are the possibilities of arranging these? So, if you would have made a list, then you would have written that A, B, C in that order, or you could have swapped the places for book C and book B, or B, A, C. Can you just give me other possibilities?
CAB,
C, A, B, and
CBA,
C, B, A, and
BCA, BCA.
B, C, A. Are there any other possibilities present?
No, I think.
No. So the 6 objects can be, so the 3 objects can be arranged in 6 ways. Now you could have gotten to this answer by other method as well. See, I asked you to arrange the book on the shelf. So the shelf has 3 spaces for the 3 books. So you're going to consider them as the spaces. So how many options do you have for the first space? If you haven't just put the books on the shelf yet, how many options do you have for the first shelf, for
Three
the
options.
first space on shelf? Yes, there are 3 options. Now on the same shelf, for the other position, you are going to have, if let's say you have placed one of the book over here and you have 2 books in the hand, how many options do you have for the second space?
Two.
2. And for the last book is going to be placed in the last. So you can multiply these possibilities out and you're still going to get the same answer. Now, 6, you had 3 books and they could arrange in 6 ways. So the result is basically same as saying 3 factorial, which was 6 ways. So if you have n objects to be arranged, the number of ways of arranging n distinct objects of n distinct objects in a line is equal to n factorial. So if there were four objects and if you were asked to arrange four objects, then फोर फैक्टोरियल बेस में अरेंज होंगे वो फाइव ऑब्जेक्ट्स होते तो फाइव फैक्टोरियल बेस में अरेंज होते एनी पर्टिकुलर क्वेश्चन स्टिल हियर
No, sir.
हैव यू कवर्ड दिस टॉपिक एट स्कूल
Yes.
okay so let's say there are nine tiles one two three four five six seven eight and nine and there is a letter these are the letters written on that. So the nine tiles have nine letters printed on them, and none of the letter is being repeated. So if you're asked to find the number of different arrangements of these nine cards, nine tiles, let's say, if there are no restrictions. The word no restriction means that you are free to arrange them in the order in any order. There are no restrictions imposed कि ये पहले आएगा या ये बाद में आएगा. So if there are nine tiles and all the nine tiles are unique, in how many ways can how many different arrangements could you possibly have if you know that there are nine tiles?
9 factorial.
Nine factorial. So what is the answer to the nine factorial coming out?
362880.
Okay, the second part says find the number of arrangements that begin with grad, meaning out of the nine tiles, the four tiles should spell like this, grad, and then the remaining tiles could be arranged in a free way. So out of the nine tiles, the first four tiles should be like this. It should begin with these tiles, these four tiles. So there is a restriction present for the first four tiles. They can't shuffle, they can't change. You need this order. But what about the remaining five tiles? Is there any restriction for that?
No.
No. So in how many ways can the other nine tiles arrange themselves?
The other 5 tiles?
Yeah, the other five tiles,
5 factorial.
five factorial. So five factorial ways में ये arrange हो सकते हैं. So five factorial is 120. 120 ways. Now part C says you need to find the
Yes.
number of arrangements that begin with the letter G and end with the letter S.
Sir,
G.
is the answer to the B part only going to be 5 factorial 120?
Yes, because you are not allowed to change these styles GRAD, that stays the same. So the only shuffling could be done for the remaining five tiles. So these five tiles are going to arrange themselves in five factorial ways, and every time you're going to have a different word.
Okay.
Okay. Now for the part C, you need to find a number of arrangement that begin with G and end with S. So again, there is a restriction. The restriction is that for the 9 tiles, starting should be with G and ending should be with S. So out of 9, 2 are gone. How many remaining tiles are left?
7.
Is
7
there any
factorial.
restriction on the 7 tiles?
No.
No. So the 7 tiles can arrange themselves in 7 factorial ways. So 7 factorial is
5040.
5040. That's correct. Okay, can I move on?
Yes.
Yes, sir.
Okay, you could also try this question. Let's say if I give you 4 squares and 3 circles. But right now you would say, okay, the 4 squares are identical and the 3 circles are identical. But what if I change the colors? Okay, I have changed the colors. Now the question says find the number. Now all the shapes are different. The shapes would have only been identical if the shape and the geometrical shape and the colors would have been equal. If you have circles but the circles have different colors, so these are different shapes. Now you need to find the different arrangements of these 7 objects if there are no restrictions. So the first part says in how many ways can these 7 objects be arranged themselves. So what do you think?
7
There are seven
factorial.
objects.
7
Yes, so
factorial.
you can arrange themselves in 7 factorial ways. That's correct. Find the number of arrangement where the squares and circles alternate. So the part B is find the number of arrangements where squares and circles alternate. So square and circle are alternating, meaning if you start off with a square followed by a circle, then a square, then a circle, then a square, then a circle, and then a square. Is the other way around possible? Can you start off with circles?
No.
Why?
Because then the two squares will be together.
Exactly. So there are less number of circles. So if you're going to start with circle, the number of squares are going to be together. Okay, now this is the arrangement. So I want squares to be on this position and circles to be on this position. In how many ways is this the possibility? The four the question does not specify which color square needs to be where. So you have an option to change the positions of the squares within them. So the squares can shuffle within themselves. If square is at one first positions, third position, fifth, and seven, so these positions you can shuffle these squares. So there are 4 squares. Would you agree that the 4 squares can shuffle in 4 factorial ways?
Yes.
Yes.
Then times there are 3 circles, so 3 circles can position shuffle themselves in 3 factorial ways. So now what's your answer is 4 factorial is 24, 3 factorial is 6, 6 times 24 is 144. Make sense? So there are 144 ways in which you can have an alternate shape arrangement. Now I need you to find the number of arrangements where all squares are together. So you are going to group them. If you want squares to be together, you're going to group them. One, two, three, four. Okay. There is no option of grouping circles. Circles are free to move, but wherever you are going to move the squares, they are going to be moving together. So you bundle them up or you group them together, and you are going to treat them as a single block. You make a block out of it. So wherever the square goes, they move around, they move as a block. Now, how many independent objects do you have on the screen that can move?
4.
3.
Four. There are three
4.
circles and one block, so there are four. So first of all, 4 factorial for the four different objects. Now, in one block, there are four squares. Can we shuffle the squares as well?
The square as the one whole block we can shuffle.
Now, in a block, there are four squares sitting. Can I shuffle the four squares within each other with each other?
Yes.
Yes. So the four squares can shuffle in 4 factorial ways. The first 4 factorial was for the four different objects. There is a block and there are three circles, so making it four. They can arrange themselves in 4 factorial ways. And then 4 factorial for the four inner squares that can arrange within themselves. So what's 4 factorial into 4 factorial?
24 into 24.
24 into 24.
504.
5, 24 into 24. वापस
No,
से कैलकुलेट
5,
करना
7,
है.
6, 5.
24 into 24, 576.
576.
6.
Okay, all right. Now, if I ask you to find me the number of arrangements where the squares are together and the circles are together, squares together, I'm not writing the all entire question, squares together and circle together, circles together. So, how many blocks would you have now? You want all the squares to be together and all the circles to be together. How many blocks would
2.
you have now? There are going to be
2.
two
2.
blocks. अब या तो सारे के सारे सर्कल्स पहले आ जाते हैं और स्क्वायर्स बाद में आ जाते हैं, या स्क्वायर्स पहले आ जाते हैं और सर्कल्स बाद में आ जाते हैं. So these two blocks can shuffle themselves in
2 ways.
2 factorial ways. Now within this block there are four squares. In how many ways these four blocks can arrange themselves?
4 factorial ways.
4.
Times
3
for
factorial
the
ways.
3
circle,
factorial.
3 factorial ways. Yes, that's correct. So what is that going to be?
288.
288. Okay. Okay. Now the question says 5-digit number are to be formed. Numbers are to be formed using the digits 2, 3, 4, 5, and 6. These are the digits, and each digit can only be used once, so no repetition allowed. Okay? No repetition allowed. First part says find how many 5-digit number can be formed. Yeah, can be formed. So, is there any restriction in this question?
No.
So, in how many 5-digit numbers can be formed?
5 factorial ways.
5 factorial ways. That's correct. Say you know the answer for the 5 factorial. What is it?
One 20.
120. Now the second part says how many of these 125-digit numbers, how many of these 5-digit numbers are even numbers? So how many of these 5-digit numbers are even numbers? An even number is a number that ends at, you you want to form a 5-digit number that is an even. How can you say whether a number is an even or not? By looking at the number, how can you come to the conclusion that a number is an even or not?
Whatever is divisible by 2 is an even number.
Whatever is divisible by 2, yes. So can I say that the last digit must also be an even number? The last digit must also be an even number, right?
Why?
The only way you can have an even number, for example, 5, 4, 3, 2, 6, is this an even number?
Yes.
Why? Because the last digit is an even number. Is this an even number?
Sir, I
No.
don't understand.
No.
And only one or two numbers are even.
Only?
Like 4 and 2 and 6 are even. How can you say
Yeah,
that the whole thing is even?
the even number, if I, okay, would you agree that 12 is an even number?
Yes.
Why do you say a 12 is an even number when the first digit is an odd number? It's the
Oh, I get.
collective term. Yeah, it's a collective term, and you always see the last digit. So even if this is a 5-digit number, this is going to be called an even number because at the end the last digit is an even number. This is going to be a odd number, entirely an odd number, because the last digit is an odd number. Okay.
Yes.
So if I want to have a 5-digit number that is even, it must end up with an even number. The last digit must be a even number. So out of these numbers, out of the pool of these numbers, 2, 3, 4, 5, and 6, how many options do I have for the last position?
3.
3.
3. Yes. So I have 3 options for this last position. Let's say I plug in 2. Do I have any restriction for the other first 4 digits?
No.
No. So in how many ways can the first 4 digits arrange themselves?
4
4.
factorial.
Exactly, 4 factorial. So 4 factorial times 3,
Sir, it won't be
72?
3 factorial base.
No. See, you have 5 digits available with you, the, and you want to form an even number. The last position can end up either with the last position can end up either with 2, it can either end up with 4, or it can either end up with 6. So there are three options. Okay, now let's say if I'm saying that the number is ending with 2, so I cancel that out, and one of the spaces has been occupied. Now for the first four spaces there are four digits, and these four digits are free without restriction. They can arrange themselves in 4 factorial ways.
No, sir,
ठीक
the
है?
three.
Hmm.
4 factorial into 3, right? Won't it be 4 factorial into 3 factorial? Because we have three options.
नहीं,
What?
you have three options. You are not arranging three distinct objects. अगर मेरे पास तीन डिफरेंट ऑब्जेक्ट्स को मुझे अरेंज करना हो तब जाकर मैं 3 फैक्टोरियल वेज में करूं, लेकिन अगर मेरे पास ऑप्शंस तीन है तो आई एम सिंपली गोइंग टू राइट 3. अब मैं ये
Okay.
क्लियर कर देता हूं कि ये ऑप्शंस कैसे तीन है. सी, दिस इज वन ऑफ द वर्किंग, और you could have made three possibilities. Since you have three even numbers, you're going to say that okay, I'm going to first find out the possibility of 5-digit numbers ending with 2. ठीक है? So out of 2, 3, 4, 5 and 6, you're ending the number with 2, so you have only one option. मैं कह रहा हूँ कि बस 2 पर ही end होना चाहिए. So the remaining 4 digit can arrange themselves in 4 factorial ways. Okay? So 4 factorial जो भी होता है 24 होता है ना. Now
Yes.
you are going to say, okay, now I want the number to end with 4. So a 5-digit number that should end with 4. Again, you have one choice. So out of these numbers, only 4 could be on the last position. So that's only one choice. So the remaining 4 can arrange themselves in 4 factorial ways. So 4 factorial times 1 is again 24. Now you are going to say that okay, now it should end with 6. So out of these digits, 6 is gone. Only one option for the last position. Okay, that was 6. Now the other 4, 2, 3, 4, and 5 are free to arrange themselves. So 4 factorial for that, again 24. So instead of adding 24, 24, 24, and getting the answer 72 and doing the working like this, for this particular question, it was easy for us to write down three options available for the last position and times it by 4 factorial. You get my point?
Yes, sir.
Any particular question you want to ask?
No, sir.
Okay. Now I'm going to do the same question but with a different part. In this part, you were asked to find even number. Now in the next part, I'm asking you to find I'm asking you to find the numbers that are greater than 40,000. Number greater than 40,000. So you have these digits 2, 3, 4, 5, and 6, and you want to form a 5-digit number, but that number should be greater than 40,000. How can the number be greater than 40,000? If it should start with what? If a number needs to be greater than 40,000, the
5 or
first
6.
number, the first digit should be.
I don't know.
How many options do you have for the first position?
5.
It can start with 4, it can start with 5, and it can start with 6. So technically there are three options for you. Let's say now once you have known the options, you're going to just yes.
Why not with 2 and 3?
Sorry, your voice is lagging.
Sir, why can't we place 2 and 3 in the first space?
Because if you are going to place 2 and 3 in the first position, ठीक है, and let's say start आपका number 2 से हो रहा है and आपने बाकी इस तरीके से अरेंज कर दिया है, is this number greater than 40,000 or less than 40,000?
Less.
Less than, but you want greater than 40,000. Even if it's
Sir, but
if the
5.
first if even if it is going to start with 3, the number is still going to be less than 40,000. You want a number greater than 40,000. यानी कि it there could be a possibility where the number could be 42,356, 42,356. That is a number that is greater than. So a number can start with 4, or it can start with 5, or it can start with 6. So there are three options for that position. Let's say you want to pick up 4. So you pick up at 4, you forget 4 now. Out of these 5 digits, 4 is gone. How many remaining digits are there?
4 factorial.
4 digits, and those 4 digits can arrange themselves in 4 factorial ways. So 72 again. ठीक है?
जी sir.
Alright. Now, what if I ask you that how many of these 5 digits जो आपने पहले find किए थे are even and greater than 40,000? I want both conditions to be met at the same time. I want the number to be greater than 40,000 as well, and it needs to be an even as well. So you need to pay attention over here now. It There is a 5-digit number. You're always going to deal with this restriction first. There are two restrictions given. Even number होना चाहिए or greater than 40,000 होना चाहिए. The digits are 2, 3, 4, 5 and 6. अब यहाँ पे it's better to do the working in steps. अगर अगर मुझे चाहिए number greater than 40,000, ठीक है, तो let's say I'm saying that a number with 4 starts with 4, ठीक है. So I deliberately want 4 to be the first number. If 4 is the first number, ठीक है, I just don't want any numbers greater than 40,000. I want even numbers to be greater than 40,000. Now I'm going to see what options will give me an even number. This last position can be occupied with which digits?
2, 4 and 6.
5.
But 4 is gone. 4 is gone.
So 2 and
4 is
6.
gone over here.
2
Yes,
and
2 and
6.
6. So I have two options for here for the last position. Either it can end up with 2 or it can end up with 6. And for the first position, I just only have one option, that is 4. So, and for the last position, I had two options, 2 and 6. Let's say you fix in 2 in the last position. Now you're left with three numbers. Is there any restriction on the three numbers?
No.
No.
So
3 factorial.
the three numbers can arrange themselves in 3 factorial ways. So 3 factorial is 6 and 6 times 2 is 12. ठीक है? This was the first case. Now I want the same 5-digit number to start with 5. So if I want the number to start with 5, I only have one option for 5 at the first place. Okay, but I want the number to be an even as well. So 5 is gone. Okay, how many options would I be left with for the last position?
3.
3. So that's why 3 options. Now you may cancel out any of the even number. Let's say I cancelled out 6. So the remaining 3 options can arrange the 3 digits can arrange themselves in 3 factorial ways. So 3 factorial is 6. 6 times 3 is 18. And one more step. The number can start with 6 as well. So if a number starts with 6, 6 is gone. Only one option. Now you want a number to be starting with 6 as well as being an even number. So how many options would you have for the last position?
2.
2.
2.
Two options, 2 and 4. Okay? So two options. Let's say I cancel out 4 for the last position. Now I'm left with 3 numbers. So 3 numbers can arrange themselves in 3 factorial. Again, 12. So the total answer, how many numbers are there that are even as well as greater than 40,000? You're going to add these values, 18 plus 12 plus 12.
42.
42 is your answer. Do you understand this question now?
Sir, is there no other way to do it more simply? We have to calculate it step by step.
Yeah, when there are two restrictions given in the same part, the two restrictions were that the number should be an even as well as it should be greater than 40,000. Then you are going to break down these into steps. Otherwise, when we were solving just greater than 40,000, we just had one step to go by. That was to start with 4. Greater than 40,000, there were three options, and the remaining would arrange themselves in 4 factorial ways. So, working was simply in one step. But when you have two conditions for the same part, two restrictions, then it's better to divide them into cases.
Okay.
Okay, done?
Yes, sir.
Okay, the next question says that there are three girls to be seated. Okay, there are three girls and two boys are to be seated in a row. Find the number of different arrangements. Find the number of different arrangements, different ways or arrangements that this can be done if part A says the girls and boys sit alternately. Do you understand the question?
Yes.
Yes.
So can you guys try this first?
Yes, sir. Sir, will it be 3 factorial into 2 factorial?
Yeah. So the options are there are five spaces. We want them to sit alternately. So the first position would be occupied by a boy, boy, and girl. Now the girls can arrange themselves in 3 factorial ways, and the boys can arrange themselves in 2 factorial ways. So is it 12?
Yes, sir.
Okay. Now the second part says a girl sits at each end of the row. A girl sits at each end of the row. So the row comprises of 5 seats. You want the girls to sit at each end of the row. Yeah. So how many options do the girls have for the first position?
3.
Three. Very good. Okay. If one of the girls sits at the first position, then how many options does the other two girls have for the last position?
2.
2.
Two. Okay. Now the two girls have sat down. There is one girl standing, and there are two boys. Is there any restriction for those three people?
No.
No. So 3
So can we
factorial.
arrange themselves? Can they arrange themselves in 3 factorial ways?
Yes.
Yes.
That's how you do this. So 3 factorial is 6. 6 times 2 is 12. 12 times 3 is 36. Okay.
Yes.
Okay, now I want you to try the last part. The girls sit together and the boys sit together. Okay, you try this out. I'm gonna answer a call and then get back to you.
Renu,
Hmm.
मैथ का काम
I think, हाँ.
मैथ का काम होमवर्क
यार मैंने कर लिया है वो भी.
लोसाई वाला नहीं, पहला वाला.
विंटर वेकेशन वाला.
हाँ,
हाँ. अभी
कर लिया.
मैं करूंगी. अभी आंसर्स
मुझे
मैंने कर लिए हैं. मैं उसको भेज दूंगी तुम्हें.
जल्दी. थैंक्स.
लास्ट वाले का 2 फैक्टोरियल into 3 फैक्टोरियल into 2 फैक्टोरियल. I think.
तो 2 फैक्टोरियल into 3. हाँ.
Okay, guys, done.
Yes, sir.
Yes, sir.
So you want the girls to sit together and the boys to sit together. So you're going to bundle them up, group them up. There are two blocks, so 2 factorial for arranging the block, and the 3 girls can arrange themselves in 3 factorial and the 2 boys can arrange themselves in 2 factorial ways. Is the answer 24?
Yes.
Yes, sir.
Okay. Okay. The other question says 6 girls and 2 boys are to be seated in a row. Find the number of ways that this can be done if the 2 boys must have exactly 4 girls seated between them. Okay, you may try this on your first by yourself. Which school are you guys from?
Bayview High.
Bayview.
Is it in Clifton?
Yes.
Okay. Near block 2? वो जो बारबेक्यू टुनाइट के पास है वो.
नहीं सर.
तो ये कहाँ पर है?
In Fairtown.
सॉरी कहाँ पे?
Fairtown.
रेड टाउन. ओके. सो मिड टर्म्स हो गए आप लोगों के?
Yes sir. Vacation से पहले हो गए.
Vacations में. How did it go? मैथ्स और एडवांस कैसे हुए थे?
Sir, maths went really bad. Add maths अच्छा गया था.
मैथ्स में was it like P1 and P2?
No, just one paper.
ओके. ऑनलाइन हुआ होगा ना probably.
जी sir. Sir, will it be 2 into 4 factorial into 1?
Let's see. 6 girls and 2 boys are to be seated in a row. So the row must have 8 spaces.
6 factorial.
ठीक है. Now the 6 girls and 2 boys are to be seated in a row. You need to find the number of ways that this can be done if the 2 boys must have exactly 4 girls seated between them. So if let's say the boy decide to sit over here, then he must have 4 girls sitting between them, right? And between the 2 boys, then the next boy should sit over here. Is that the case? If the first boy decides to sit over here, then would you agree that the second boy would be sitting over here?
Yes.
Yes.
Okay, that's one of the possibility, right?
Yes.
Now, what could be the other possibility? What if the boy plans on sitting over here first? Then, where would the second boy be sitting?
In the 7th seat.
Seventh seat. So that is going to be one possibility of all sitting like this. And if the boy sits on the third place, the other boy would be sitting at the last seat. Okay? So there are three options. You are going to pick up any options. See, there are three options. You are going to pick up any option. Now, let's say if we go by this option that we would, the first option, that the boy decides to sit over here, and then the next boy is going to sit over here, and there are going to be 4 girls in between. Okay, right?
Yes.
All right. Now, is there any restriction on the girls?
No.
The remaining 2 girls can sit on these places as well. So, three options are गए आपके पास. Now, what about the 2 boys can arrange themselves in
2. 2 base.
2
2
2
ways.
factorial.
factorial. Let's say अहमद यहाँ बैठ गया, एहसन यहाँ बैठ गया, और एहसन वहाँ बैठ गया, अहमद वहाँ बैठ गया. So there are 2 factorial ways. Now, for the remaining 6 girls, in how many ways can the girls arrange themselves?
6 factorial.
6 factorial. Do you guys understand the question?
Yes.
Yes.
There are 3 options were for like 3 ways of arrangement that could be done, right?
3 ways of sitting that could be done
Yeah.
over here. Done. So what's the answer coming?
4320.
4320. Okay. All right. So far we haven't started permutation. Okay. We haven't started permutation combination. It was just the basics of arranging things, arranging all the things. Now, the next thing that we are going to do is permutation. Permutation में क्या होता है कि let's say you have 8 objects. Let's say you have 8 books, but I just want you to keep 3 books on the shelf because there is only a space of 3 books. And now, if I ask you in how many ways can you place 3 books on the shelf?
3
Are
factorial
you
ways.
understanding? Are you understanding the question?
Yes.
There's a difference between the concept that we have done before and the concept that we are doing now. Previously, we just had 3 books and you said 3 factorial ways में वो arrange हो जाएंगी. ठीक है, क्योंकि फर्स्ट बुक के पास यहाँ 3 ऑप्शन थे, then 2 options, then 1 option. ठीक है, that was before. Now basically you have 8 books. but you still have three places for the books, three spaces for the books. So you need to first choose the books, and then you're going to arrange the books. Okay, because we need to arrange them as well. So if I ask you how many options does the first position will have?
8.
Yes, it is going to have 8 options. Any of the 8 books can be kept on the first place. Let's say you kept one of the book. Now you will have how many books to be kept? How many books are there with you?
7.
7.
7. So does the second place will have 7 options? And
Yes.
then the
Yes.
next will have 6 options, right? So 8 into 7
Yes.
into 6 is what?
336.
336.
336 ways. Now you can link that concept with permutation, which means different arrangements of the books. And this is the notation that you can use. Out of 8, you are going to permute 3 books. Now this means 8p3, this is read as 8p3, and this means first of all, out of the 8 books, I am going to select the 3 books and then arrange the 3 books in 3 factorial ways. Now NPR in permutation has a formula, and NPR is equal to n factorial over n minus r factorial. So if I have 8p3, the value of n is
8.
8 divided by 8 minus 3 factorial. So 8 minus 3 is 5, 5 factorial. Can you solve this without the calculator? What is 8 factorial going to be? 8 into 7 into 6 into
5 factorial.
5
5 factorial
factorial.
divided by 5 factorial. If I cancel that out, would I be getting the same thing? 8 into 7 into 6, that is 336 ways.
Yes.
So the concept says that if you have 8 books and you need to arrange 3 books on the shelf, you're going to do 8p3 in the calculator. Do you girls know how to solve 8p3 from the calculator?
Yes.
Okay. So you're going to press 8p3 in the calculator and you're going to get 336 as well. So this is how you're going to permute r items from n distinct items. परम्यूट का मतलब होता है अरेंजमेंट, ठीक है. So you are going to permute r items from n different items. So if I want, so one thing is clear that in permutation order does matter. Okay, you just can't select the books, the order is going to matter. Is that clear?
Yes, sir.
Yes, sir.
Okay, चलो फिर I'm going to continue tomorrow from here. ठीक है.
Thank you, sir. Bye.
Okay, you're welcome. Allah Hafiz. Bye bye.